In the last lecture, we were studying about object transformation. And by transformation, we mean that we move the coordinates of the object in some way. So there are 5 possible ways in which we can change the coordinates of an object. The coordinates mean the x and y position of different pixels of that object. Okay, so the first way of object transformation is the translation or shifting. Okay, so when we translate or shift an object from one position to another position, so it changes the pixels of that object. The second one is we change the size of the object. This is known as scaling. The third one is the rotation. Okay, so we consider a point, okay, and an angle, and we rotate the object about that angle at that point. Then there is reflection, which is mirror of an object, and finally shearing. So we already studied about the translation. Okay, that translation means we add actually some points some values tx and ty, okay, to the original position of x and y, so that will give us a different position of the object, and we can write this in the matrix form as you can see here. The next thing was about the rotation. Okay, wait. So this is another way of writing, the matrix of translation. The next one is about, the point here is that if we want to translate a line, okay, then we will translate its endpoint and we will redraw the line again. We will see that how is it possible. Okay, then translating a polygon and translating a circle. Okay, there were some examples of translations. Okay, we have seen them, and this is how we do translation in OpenGL. Today we will see how we can do translation in Canvas. Okay, so the same code you can see here, that the code here and the code here, this is exactly the same, okay, except that there is a translation between the two. Okay, so the first code and second part of the code, there is a translation. So the output is that we have two, what is this line loop? It will create a square. So we have two squares, but at different positions. Okay, then the next thing is about the scaling. Okay, which means that we want to increase or decrease the size of an object and increase or decrease on some values. So for example, for square, we will actually increase one side or the another side because there are x or y position. In case of a circle, we will change the value of the radius to give it a different scaling. Okay, so scaling is uniform if both the x and the y scaling axis, they are same. If they are not same, then this is called differential. Okay, this is an example of scaling. Okay, how do we do scaling for increasing? So when we have doubled the size, so x and y, they are doubled, so it means the size is increased or doubled. Then the next one is about using 0.5. So in this case, we decrease the size. This was the original size, we decrease this to half. Okay, and this is the change that 4 has reduced to 2, and 3, it should be 1.5. I told you, and this should be 1.5. There is an error. Okay, so these are the examples of scaling. After scaling, we have, okay, there is also the code of scaling in OpenGL. How do we do scaling in OpenGL? So the example here shows, once again, the same code here and the same code is here, except that before the second code, we use the GL scale. Okay, so this GL scale means we are passing 2 and 2, which means in the x-axis on the y-axis, it will scale twice, so it will double the size. Okay, and 1 on the z-axis, because it's 2D, so we don't do any change on the z-axis. And after doing that, we see that the original white rectangle or square, it becomes, I mean, we have given the red color, but it is bigger. Okay, then rotation was the third one. We did not discuss it. What is rotation? We move a point around some origin or around some reference point, okay, by some angle. So what did we do for the rotation? So we consider this as a vector. Okay, xy is a vector here. Okay, and this is my reference point. So I rotate this vector to this point. So for example, originally my vector was this. After rotation, my vector becomes this. So this is my vector. This is a change in rotation. So this much angle. theta is the angle in which I did some rotation. Okay, now this rotation here is around this point, or it can be around the, this, I should say, origin. Okay, so we need to select a point of origin around which we can rotate. So here we consider a rectangle with coordinates 1, 1, 3, 1, 3, 5, okay, and 1, 5. And we want to rotate it 45 degree about the point 1, 1. Remember, we are not rotating it about 0.00. We are rotating it at 0.11. So we'll use the equation in which xf and yf, they are 1, 1. Angle theta is equal to 45 degree. And this is a formula that x dash is equal to xf plus x minus xf cos theta, okay, and then minus yf sine theta, and y dash is equal to yf plus x minus xf sine theta plus y minus yf cos theta. So now this is an equation that has been developed, and you can actually derive this equation yourself. Okay, it's possible to make this equation yourself. It's easy from the matrices, but this is not important for us right now. So what will happen if we use xf and yf to be 1 and we use 45 degree? How did we do this? So do you know what is cos of 45 degree? And what is sine of 45 degree? Do you know this? The value? So I can tell you that cos of 0 degree, this is equal to 1, and cos of 90 degree, this is equal to 0, and cos of 0 degree is equal to 1, and sine of 90 degree is equal to 1 also. And cos of 90 degree is equal to 0, and sine of 0 degree is equal to 0. Okay, that is something you should know this from mathematics. Okay, cos of 0 is equal to sine of 90, which is equal to 1, and cos of 90 is equal to sine of 0, which is equal to 0. Okay, so we have different values. Then we also know that we discussed this before, that pi radians, pi is equal to 180 degree. We discussed this when we were discussing arc. Okay, 2 pi is equal to 360 degree. Okay, pi by 2, this is equal to 90 degree, and pi by 4 is equal to 45 degree. Okay, so 45 degree here we want, so this is equal to pi by 4, sorry. So we will use here pi by 4 and sine of pi by 4 and cos of pi by 4, and it has its value. You can search Google, for example, that what are the values of pi by 4. Okay, so they are 0.5. The value of both of them is 0.5. Okay, so when we put these values, okay, so we will get what? Original value of 1, 1, it remains the same as 1, 1. Okay, there is no change. Then the 3, 1 point, okay, which was this point, it became this one. 3, 5 changed to this one, it becomes negative, you can see. Okay, and 1, 5 also becomes negative. Why it became negative? This is strange. On x-axis we go to negative. Okay, that is something you can see from equation, that on x-axis we got 2 points which become negative. Why? Okay, let's see that. So in OpenGL we will use the GL rotate function. We will give some angle and we will give x, y, z. Okay, so here are the values in OpenGL. We give 45 degree, 0, 0, and the z-axis is, the same as 1. Okay, so let us see that this is the same code. Okay, we just use GL rotate, and the same rectangle which is here, we also define once again here, and then the change will be that we get this. Okay, so actually this is C, the x-axis is on the negative side. Okay, x-axis become negative because of the rotation. So the original one was this. Okay, no rotation. When we move by 45 degree, so actually this came here. If I draw it again, okay, so this part it came here, this part it came here. Okay, this part remains the same. That's why it was 1 1 or 0 0. Okay, and this part it came here. Okay, so this is how we rotate it, and when we draw it, then it gives us a new square. Okay, at a different rotation, even though the origin is same 0 0. Okay, so we did translation, we did scaling, and then rotation. The fourth one is the reflection, X. Okay, what is reflection? The equation for reflection with respect to x-axis, that for each point xy, the new point will be x minus y. This is x-axis, and this is y-axis. So we are talking about x-axis, around x-axis. So when we move it around this to the next position in the x-axis, you see we have changed around the x-axis from positive top to negative. Okay, but this axis, around this axis, we have changed. Okay, so it's like rotation around this axis. So this point, if it was 1, then here this becomes minus 1. Okay, on y. Okay, so here let's say this is y1, y is minus 1. Okay, here the value of y was, let's say, minus 5, and here the y of value was 5. So we changed the value of y. You should not confuse. We have reflected, okay, we have done the reflection or x against the x-axis. Okay, but the change is in y-axis. The value of y has changed in all these points. Okay, that's important to understand. Reflection against x-axis. Now if I do reflection against y-axis, this is y-axis. So if I do a reflection, so I will have this. Okay, now this x is positive here, it will become negative here. This x is positive here, it will become here. And this x is positive, it will become here. Y is same here, and y is same here. Okay, only x-axis will be changing if you do on the y-axis. So for x-axis reflection, it is this. If I go back to the next one, which is the y-axis reflection, then it will look like this. Okay, this is a reflection against y-axis. Now here the value of x will change from positive to negative. You can see, okay, positive x is changed to negative x in all the 3 points. Okay, then if you want to change both axes, x and y, okay, so what will happen? This point on x, y-axis, it changed, it will come here, and on the y-axis it will come here. This point it will come here, and this point it will come here. So we will have this thing if we do reflection on x-axis and on y-axis, on both sides. Okay, so it will not be this one. Okay, it will be the axis around both. Okay, so both the x and y, they become negative. X was positive, it became negative. Y was positive, it became negative. Okay, now here is example of reflection. Consider a rectangle with these coordinates and reflect it with respect to x-axis. Okay, so x-axis reflection means that we will change the values of y. So when y is 1, it will become minus 1. When y is 5, it becomes minus 5. Okay, which we can see on these two sides. And this is around y-axis, which means that we will change the value of x to be negative. So x is plus 1, it will become minus 1. If x is plus 3, it will become minus 3. And we reflect it with respect to origin means that both x-axis and y-axis. So both the x and y, if they were positive, it will become negative. If they were negative, it will become positive. Okay, so any question in these things, reflection, etc.? No questions in reflection? Anyone? It's clear? Okay, good, excellent. Excellent, excellent. Okay, so now what I will do, we will actually do some coding. Okay, so let's do some coding, and I will share the entire screen with you. So what we have is, I will have the translation first. Okay, there is some code on translation. So where is the translation? you see that this is the same thing as we already know. Okay, this is the same thing. The only thing important, these lines. Okay, so what I do is that I create, a rectangle 0, 0, 100, 100. Okay, then I do a translation and I change the color to 255. Okay, red. So before, if I don't change, it means it is black. Okay, then I change it to red and I have the same rectangle. Okay, you see this line and this line, they both are the same. The only difference between them is that I have done a translation 150, 150. So what do you think will be the output? Think about that. The first triangle, this rectangle, it will be on the origin. It will start from 0, 0. Let's say this is 0, 0, and 100, 100 will be the width and height. Okay, so if 100 is here, then the next one, it will start from 150, which is here. So the next one will be looking like this. So there will be a distance between a rectangle or a square which is here and a square which is here. There will be some empty distance. Okay, so let me run it and we can see how does it work. Okay, so the first one, it starts from 0, 0. This is 100 here. This is 100 here. Okay, and then this is 50. Why this is 50? Because the second one starts from 150. This is 150. Okay, and 150 in this way. Sorry, this is again 100 and 100, but this distance is 150 from the top. Okay, so how do we get to 150? Because I have used 0, I didn't use 150. The reason is I translated my origin to 150. Okay, so now after the translate, after this one, okay, this line, if I draw anything, it will consider this 150 at 0. Okay, this is the translation. So what I have translated is the coordinate system. The coordinate system, initially it was at 0, 0. Now I moved my coordinate system to 150, 150. This becomes my 0 actually. This is how it works. Okay, my 0 becomes this one. Now if I draw the same thing, but my coordinate system has actually translated. And this is how it works. We translate the coordinate system so that the new origin is at a different point. Okay, now if I translate just, let's say instead of 150, 150, if I translate it to 100, 100, okay, so it means that I will, if I don't refresh, I just show you. So my 100, 100 is this point, and I translate it to 100, 100. So this one, it should start from here. Okay, after refresh, you can see. Okay, now anything I draw, it will be 0, 0 here, and this will be the new thing. Okay, so normally in the positive values, I cannot draw here, not draw anything here. Why? Because this is my origin, and everything here is what I can draw, but everything above 0, 0, etc., that should, let's say if I use positive numbers, that should not be there. Is there any question in this? Because I think it's very simple. Okay, and the same thing we will do in OpenGL. That here will be the code for drawing a rectangle, then we will do translate. Okay, GL translate, and then we will have another code, the same code, copy from the above, and it will create a different translation. Okay, after translation we have scaling. Okay, and this is the scaling. What's scaling here? Okay, let's see the code, then we'll come back. Okay, so in the scaling code, what you see here is that I have a okay, created a rectangle at 0, 0, 100, 100. Yes, who has question? RGB command does not work with you. Which RGB command? If you see here, I have used this is without RGB, blue, and here RGB. So for RGB, you should actually put it in quotes and do it like this. Okay, so it is a string actually. So within the quotes, you will have the string RGB. Okay, I hope this was the problem. So what I do here in the scaling is that I have one rectangle at 0, 0, size 100, and then let's say I scale it at half. I will scale at 0.5, 0.5. Okay, and the fill style for the second one is blue, and now I do it again. Let's say I do it again at 0, 0. I don't move it. I do it at 0, 0, same thing. Okay, but before the second one, I did a scaling. So what will it look like if I do it before a second one? Okay, so you see this is half. The origin is still the same. Now here is the important thing. The origin is same because I did not move the origin. I just changed the size. So origin is 0, 0, 100, 100. Origin is 0, 0, 100, 100. There was no translation. But before the second one, I did a scaling. So this is 0.5. If I make it 0.25, for example, even smaller, that will be 1/4. That will be very small. Okay. This is 0.25, 0.25. So this is 4 times smaller in each side. Okay. I can even make it bigger if I want. Instead of 0.25, I can make it 1.25. 1.25 means it is bigger than 1. So it is 25% more than the existing one. So the blue will be on top of the black one. So we will not see any black. Okay, so this has become bigger than using, and even I can have different sizes. Okay, so this is uniform scaling. I can actually reduce on one side. Okay, so on one side I reduce it 0.075, and on the other side I have increased it. So I'm not sure if you can see the difference. Okay, so on this side, okay, I have increased the scaling, and on this side I have decreased the scaling. Okay, so on y-axis I increased, and on x-axis I have decreased. Similarly, I can have different one, both let's say one is 0.7, one is 0.5. Okay, so the difference is like this. On this side, this is 50%, half. On this side, this is 75%. So this is 75%, and the remaining is 25%. So this is scaling. I can combine these two together, the scaling and translation, rotation, etc. Let me go to the next type, which is what is this in the sixth one? Let us check. Okay, this is transformation in Skew. Okay, which is shearing actually. Oh, we did not discuss shearing. Yeah, okay. Let's ignore this for the time being. Somehow we missed that. Let's go to rotation, which we see what is rotation. Okay, so what do you see here? We have initially a red color. We created a rectangle at position 0, 0 whose size was 50, 50. Okay, and actually we created this stroke rect. Okay, so this is around the canvas 0, 0, 495, 495. This is the canvas size, so we have a line around the canvas. Then we translate 200, 200, and we rotated it. Now this is 45-degree rotation. Okay, pi by 4. So pi by 4, we are actually specifying this not in 45 degrees but in radians. So this is the value of pi by 4, and pi by 4 is equal to 0.7854. So we rotate by 45 degrees. Then we have another one. Okay, and the canvas, actually we draw another line around the canvas. So this is the same like before. Okay, and then we have another rectangle at this position, and we rotate it again, and we translate it, and so on. So what do we see? This is a little bit complex. You need to practice it actually yourself to understand this. We see these different things. What do they mean? Why is it like this? Actually, we translated this. Let me explain this. If we don't rotate, here I see the code. Let us do it one by one. Okay, so let me do it all one by one, and then we will see step by step. So you will understand what's happening. Okay, so what's here now in the very first thing? Okay, only 2 lines. First we have the color red, that's for sure. Okay, then we create a rectangle at position 100, 100, and its size is 50, 50, and we have an outline of a rectangle at 0, 0, 495, 495. Why did we want this 495? We wanted to see the canvas. Okay, so this is the actually canvas we can see. So if I refresh this, this is how it will look like. Okay, This is my, fill rect, and this is my canvas. Okay, I hope you understand this. The position here is 100 by 100, and the size here is 50-50. Okay, and this is the canvas, which is the fill rect. Now the stroke rect. Now the stroke color is black or gray. Okay, because we did not change the stroke color, so it remains the same. Only we change the fill color to red, which we can see here. Next, I translate the canvas, okay, the context actually, but it will not do anything because we don't draw anything. So if I refresh this, we don't see anything. We have just translated, okay, but because we cannot see canvas, so we don't see anything. After the translation, okay, let's say after the translation, I again do this. I draw again the same thing. I just did the translation. Now what will happen is that this thing, it will create a rectangle, okay, but at this translation 200 by 200. Okay, so if I see it now, save it. If I see it now, this is actually the new canvas, okay, at position 200 200. Okay, so anything now, this becomes my 0 0 because I have done translation. So this becomes my 0 0. Now if I'm going to rotate this canvas, which is this, okay, if I'm going to rotate, it will be rotated around this point. So see this point near this square. Okay, so if I rotate, it will be rotating around this point, which you can see is that I will do rotate now, just the rotate. Okay, so before the stroke, first I translate by 200 and then I rotate it. Okay, so the translate and rotate both, it will create this. Okay, if I want to rotate by not by 45-degree, okay, but let's see, I want to rotate it by 90-degree. Okay, 90-degree. So 90-degree means it's double of this, okay, or pi by 2. What was pi by 2? Mass dot pi divided by 2. That is the 90-degree. Okay, so if I try this, you can see this is 90-degree rotation. So originally this one, when I rotate it by 90-degree, it looks like this. Okay, let's say I change this to 250. Okay, not 200, but 250. So originally it came here 200, 250, it will come here. Okay, so if I refresh it, you can see it's this point 250, and this is the rotation afterwards. Okay, so this is the difference of rotation and scaling. Now important thing is that if I change the order of rotation in translation, if I do rotate first and translate second, it will give me different result. Why? Think about this. I repeat, here I translate first, then I rotate, so it gave me this thing. Now if I rotate first and then translate, that will give me a different result. Okay, you can verify that yourself, you should try it. Okay, after that I have another rectangle, okay, at position 40 80 and 100 100. Now see what should be the position 40 80. This is my position 0 0. This is my x-axis now, and this is my y-axis, because originally this x-axis after rotation it becomes here, and this y-axis, which is here, it becomes this one. Okay, so if I draw something now at 40 80 100 100, so from this point x-axis 40 is here and y-axis 80 is here. Okay, almost. So it will draw here a square of size 100 100, okay, which is from this origin 40 in x-axis and 80 in y-axis, because my new x-axis and y-axis are these one. Okay, so let me save this to show you how does it work, and you can see this. Okay, this is how we create a new one. Now if I change this rotation, let's say I don't want this to be 90 degree, I want this to be 45 degree. Okay, so what will be the change? The change will be that it will be something like this. Okay, and this will also be not 90 degree but 45 degrees, so it is here. Okay, now again I rotate back 45 degree, which means it will go back to original position, and I will translate back to, because I have translated it 100 100, sorry, translation is 250 250, So I will translate back to 250, 250 here. Again, this is minus. Okay, so this will reverse the thing. Okay, what I did here, first I translate it and then I rotate it. Now I do the opposite. Here I first rotate it in the opposite direction and I translate it in the opposite direction. So this should do the same thing like original. After this, my origin now here is 0, 0. If I draw anything now, it will be according to this x and this y. Okay, so what I do now is stroke rect. It's the same thing, don't need to do it, but this time I have a fill rect of 150, 150 and 50, 50. So this was 100, so 150 will be here. So it will be like this. Okay, you can see in this I created 150, 150. Okay, and if I translate it again by 60, 20 and I draw something, you should realize yourself how does it work. Okay, it covered the whole thing. Why? Well, actually, let me make it different. Let me make it 140 and 180, let's say. Okay, so you can see it's like this. Why is it like this? Think about that. That is very actually, mathematical and logical. There is nothing difficult. This is about understanding the translation and rotation. If you understand how do we make translation and rotation, translation is easier, but rotation is a little bit difficult. If you understand that, then that will help you. Okay, so these lines here, I just wanted to draw it to show you that this is my canvas. These, these lines. And on top of that, I drew these different squares. Okay, similarly, I can have circles, etc., all things drawn on this. But you see that using translation and rotation, I created shapes at different things. Any question in that? Do you understand this, or this is difficult? I suppose it's easy. Just you need to understand and read it. Okay. Now this was about translation and rotation. Okay, scaling we also studied. All the three examples we studied that. Okay, now let's move back to the canvas slides. Okay, we were doing canvas before, and even now I did some canvas coding, but let's resume the canvas slides once again. Just give me a minute. I'm loading the slides. Okay. So the transformations, we know about translation. What is translation? Okay, so we move the context. Originally the origin was this 0, 0. Okay, and then I moved it. The origin is now this. So anything at 0, 0 will now be here. Okay, that is a translation. The example is that we have the same code to fill rect, but before translation and after translation it will be different. Okay. About scaling, yes, we did a scaling of 2, 2 before drawing the same thing, for example, and it will give us a different result. Okay, so here is an example. One more thing is about context.save. What does it mean? Context.save means we save the value of origin, we save the value of color, of the stroke color, and of the fill color. Okay, so I want to save this. Then I will make a translation to 150, 150, which will here. I made a scaling of 2 by 2. Okay, and I created this. So a scaling of 2 by 2 means that actually the fill rect will be 0, 0, 200, 200. So this size is 200 and 200. Remember this. This is not 100, 100. Why? Because my scaling has been 2. So every x and y will be multiplied by 2. So this will become 200 and 200. Okay. Then restore means I will use the same old value. What was the old value? In the old value, my context was here. My origin was 0, 0, which was here. Now, if I draw the same 0, 0, 100, 100, so you can see it starts at 0, 0, and this is the size 100, 100. Okay. Remember, I want to make the point that here I have used 0, 0, 100, 100, which created a big one. And when I again use 0, 0, 100, 100, so it created a small one. Why? Because before in this one, I had a scaling of 2 by 2. Okay, so it created twice big on X and Y axis. When I say context.restore, it simply means I want back this condition, okay, which was that the scaling was 1 1. So I'm using the same scaling and I have created these two. Okay, the same thing you can do in different ways. Without scaling, for example, you can see the size, you can change the size to 200 200, let's say, okay, and you can have different positions, but we want to show you that how does it look like. That is the example of scaling. Then the rotation I have explained to you, okay, that if you just rotate the context by 45 degree and you have at this point, okay, it will create this. Half is outside the page. Why is it look like this? Okay, because it's explained here. So originally my x-axis was here. If I draw it here, this was my x-axis originally. This was my y-axis. When I made a 45-degree rotation, so 45-degree means this angle. Okay, so my x-axis becomes here and my y-axis now become here. Now if I draw anything about 150 150 100 100, so from here I will go 150 in this direction and I will go 150 from this direction, so it will be this point. Okay, and where I'll draw something, it will be this, and I will only see this part, which is here. Okay, this is logical. There is nothing as such magic, but this is about logical, that how I see this. Now my question next is this one. Okay, how can I achieve this? What should I do? That is interesting. Okay, so actually in this case, you know, my origin, it's here. Okay, so if I want to draw here, so I will translate my origin. Okay, I translate my origin from this point to this point. So I did a translation of x-axis only. Okay, so if I translate x-axis, then it will come starting from this position. Okay, so you can achieve this by translation and, sorry, first by rotation, then by translation. Okay, next is about order of transformation. I told you that the transformations, they are not commutative, which means that you cannot replace, you cannot change the order. Okay, so if we translate first here and then rotate, okay, and then if we translate rotate here, let's say, then they will not be the same. Okay, they will be actually different if you try it. What we are doing here is that actually this will not give the same result. Why? Because we cannot change the order. So if my original thing is that I had rotation first, no, sorry, here is translation first, then I did rotation. So if I want to try back to get back the original position, I will do the rotation first, it will be opposite, and then the translation. Okay, this code, if you try, and I suggest that you try this code, if you try this code, actually you would not get the same results. You need to change actually these two. If you change these lines, then you will get back the original thing. Okay, then one more thing is that in the transformation there is one more thing, which is about the skewing or shearing. Okay, skew or shear is what? It means that if I have, what is skewing? Okay, I will explain. If I have, let's say, this square or rectangle, and I do rotation, so it will become like this. It is clear. Okay, but if I do skewing, so these points will remain the same, for example. Okay, they will remain the same, but the top points, they can be something like this, or they can be something like this. Okay, if I want skew, or I can have skewing that these 2 points are the same, but I make it like this. Okay, or I make it like this. So it is changing the shape. Okay, so how do we change the shape? Using the x skew and the y skew. Okay, so this is actually one, you see, matrix which contains the scale, the skew, the translate, all those three things. With this matrix, I can translate by position x and y, I can scale by position x and y, and I can skew by position x and y. Okay, how do we do this? Well, I don't want to do this. This will be actually your homework. So try to understand that how do they work. Okay, so I will give you some example, and you have to understand that what is the skew, okay, and why does the skew change the size of the or the shape of the actually the rectangle, etc. Okay. One more concept is that of the identity matrix. Okay. What is identity matrix? A matrix in which all the values on the diagonal, they are 1, and the remaining values, they are 0. So that is the identity matrix. Okay. So when we start actually first time the canvas, its transformation matrix is the identity matrix, which means that it will not change anything, no scaling, no skew, no translation. But when we change the values, okay, when we change the values, we get something like these. Okay, so the one which was here, there was 1, I changed this one. Initially that was 1, here it was 0, it was 0, it was 0, it was 0. Okay, so if I replace the ones by X scale and Y scale, okay, and if I replace those two zeros here by X skew and Y skew, and these two zeros by some translation number, so it will give me a transformation matrix with different numbers. Okay, that is actually mathematics, and it only comes through practical programming if you do it. Okay, we will take a break of 10 minutes, and then we will start again with the transformation matrix and next things. Okay, if you have any question, you can ask me after 10